Solving problems involving tests of hypothesis on population mean, Module 8. Hypothesis testing is a statistical method used to make inferences about a population parameter based on a sample data. It involves formulating two competing hypotheses, the null hypothesis and the alternative hypothesis. The null hypothesis typically represents a difficult assumption or a statement of no effect, while the alternative hypothesis represents the opposite. The process of hypothesis testing involves: number 1, formulating the null and alternative hypothesis. Number 2, selecting an appropriate statistical test based on the type of data and research questions. Number 3, collecting sample data and calculating a test statistic. Number 4, determining the probability of obtaining the observed test statistics. Or one more extreme, under assumption that the null hypothesis is true. This probability is known as the p-value. Number 5, the p-value to a predetermined significance level alpha, typically set at 0.05. Number 6, if the p-value is less than alpha, rejecting the null hypothesis is favor of the alternative hypothesis, otherwise failing to reject the null hypothesis. Number 7, drawing conclusions based on the results of the hypothesis test. In short, hypothesis testing is widely used in scientific research, business analytics, quality control, and various other fields to assess the validity of claims and make informed decisions based on empirical evidence. Statistical inference. Hypothesis testing allows researchers to draw conclusions about population parameters, such as means, proportions, variance, and etc., using sample data. Number 2, testing research hypotheses. In scientific research, hypotheses are often formulated to test specific theories or predictions. Number 3, decision making. Hypothesis testing proves a basis for decisions making in various fields, including businesses, healthcare, and policy. Number 4, quality control. In manufacturing and process improvement, hypothesis testing is used to assess the quality of products or processes. Number 5, risk management. By specifying a significance level alpha in hypothesis testing, decision makers can manage the risk of making type I errors, rejecting a true null hypothesis, and type errors, failing to reject a false null hypothesis. Number 6, validation of models. Hypothesis testing is often used to validate statistical models and assumptions. Overall, the purpose of hypothesis testing is to provide a systematic and objective approach to evaluating hypotheses, making decisions based on data, and drawing valid conclusions about population parameters. This is a simplified overview of hypothesis testing for a population mean. The specific details of the test may vary depending on factors such as the sample size, whether the population standard deviation is known, and the assumptions made about the population distribution. Absolutely. The alternative hypothesis H1 or HA complements the null hypothesis. And hypothesis testing, it represents the statement contrary the null hypothesis, indicating the effect, difference, or association being sought in research question. In essence, the alternative hypothesis reflects the researcher's hypothesis or the assertion their investigation, and it suggests that there is a genuine effect, difference, or relationship present in population. For instance, in the scenario of testing a population mean, the alternative hypothesis might assert that the population mean differs from a specified value, where H1 represents the alternative hypothesis, represents the population mean, and represents a specified value of the population mean. This alternative hypothesis suggests that there is a difference between the population mean and the specified value, as opposed the null hypothesis, which assumes no difference in various hypothesis testing contexts. The alternative hypothesis can take different forms depending on the research questions and the nature of the effect or relationship being investigated. It could involve greater than, less than, or not equal comparisons, depending on the specific hypothesis being tested. Assumptions and conditions. In hypothesis testing, certain assumptions and conditions must be met to ensure the validity and reliability of the results. These assumptions and conditions vary depending on the specific hypothesis test being conducted, but some common ones include random sampling. The samples used in the hypothesis test should be randomly selected from the population of interest. This ensures that the sample is representative of the population, allowing for generalization of the results. Independence. The observation within the sample should be independent of each other. This means that the value of one observation should not be influenced by the value of another observation. Normality. The population distribution should be approximately normal, especially for small sample sizes. For large sample sizes, the central limit theorem often ensures that the sampling distribution of the sample mean is approximately normal, even if the population distribution is not. Homogeneity of variance. When comparing two or more groups, the variances within each group should be approximately equal. Violation of these assumptions can affect the accuracy of hypothesis tests such as the test or ANOVA. Sample size. The sample size should be sufficiently large to ensure the validity of the hypothesis test. Measurement scale. The data should be measured on an appropriate scale for the chosen hypothesis test. Linearity. When conducting regression analysis, there should be a linear relationship between the independent and dependent variables. It is essential to assess whether these assumptions and conditions are met before conducting a hypothesis test. Violations of these assumptions can lead to biased results and incorrect conclusions. If assumptions are not met, alternative methods or adjustments may be necessary to ensure the validity of analysis. Test statistic calculation. The test statistic is a numerical value calculated from sample data and is used to assess the strength of evidence against the null hypothesis. In hypothesis testing, the specific calculation of the test statistic depends on the type of hypothesis test being conducted. Here are examples of how the test statistic is calculated for commonly used hypothesis tests. One sample Z for population mean, known as population variance. Number 2, one sample test for population mean, unknown population variance. Number 3, two sample tests for difference in means. Number 4, chi-square or chi-square? The chi-square test in independence. These are just a few examples of commonly used hypothesis tests and their corresponding test statistics. Depending on the specific hypothesis test and the research question, the calculation of the test statistic may vary once the test statistic is calculated. It is compared to a critical value or used to calculate a p-value to determine whether the null hypothesis should be rejected. Determining the critical region. The critical region, also known as the rejection region, is the range of values of the test statistics that leads to the rejection of the null hypothesis. It determined based on significance level alpha chosen for the hypothesis test. To determine the critical region, choose a significance level. The significance level denoted by A is the probability of rejecting the null hypothesis when it is actually true. Commonly used significance level include 0.05 or 5% and 0.01 or 1%. Select the test statistic distribution. Depending on the hypothesis test being conducted, and the test statistic typically follows a specific probability distribution, etc. Normal distribution, t-distribution, chi-square distribution. Find critical values using the chosen significance level and distribution of the test statistic. Determine the critical values that define the critical region. These critical values represent the boundaries beyond which the null hypothesis is rejected. Identify the critical region. The critical region consists of the value of the test statistic that lie beyond the critical values determined in step 3. These values indicate extreme outcomes that are unlikely to occur if the null hypothesis is true. For example, in a one-tailed test, either upper-tailed or lower-tailed, the critical region is located entirely in one tail of the distribution. In two-tailed tests, the critical region is divided between both tails of the distribution. Once the critical region is determined, if the calculated test statistics falls within this region, the null hypothesis is rejected in favor of the alternative hypothesis. If the test statistics falls outside the critical region, the null hypothesis is not rejected. It's important to note that the determination of the critical region depends on the specific hypothesis test being conducted as well as the chosen significance level and the distribution of the test statistic. Conclusion and hypothesis testing. Drawing of conclusion involves interpreting the results of the statistical analysis to make a decision regarding the null hypothesis. Here's how the conclusion is typically made. And it is essential to communicate the conclusion clearly and accurately, taking into account the limitations of the study and assumptions made during the hypothesis testing process. Additionally, it's valuable to provide context for the findings and explain their significance in relation to the broader field of study. Example problem. A researcher wants to investigate whether a new teaching methods improve students' test scores compared to the traditional teaching method. The researcher randomly selects a sample of 30 students and administers a test. The mean of score for the sample is 85%. With a standard deviation of 10, the researcher wants to test the hypothesis that the mean test score for students using the teaching method is greater than 80. Critical region. Since this is one-tailed test, we are testing whether the mean test score is greater than 80. The calculated test statistic t equals 7.75 falls into critical region. Interpretation: there is sufficient evidence to conclude that the mean test scores for students using the new teaching method is greater than 80%. Therefore, the new teaching method appears to improve students' test scores compared to the traditional method. This example demonstrates the steps involved in hypothesis testing for a population mean and how to interpret the result in the context of the research question. References: textbook. There are many textbooks on statistics that cover hypothesis testing in depth. Some popular options include Introduction of the Practice of Statistics by David S. Moore, Statistics by Friedman, Pisani, and Probs, and Statistics for Business and Economics by Paul Newbold, William L. Carlson, and Betty Strone. Online course website like Coursera and Udemy offer online courses of statistics. And academic journals in fields such as statistics, psychology, sociology, and economics often publish researchers' articles that use hypothesis testing. Documentation for statistical software packages like R, Python, Skippy library, and websites and vlogs. There are many websites and blogs dedicated to statistics and data analysis that provide tutorials, articles, and resources on hypothesis testing. By exploring these resources, you can deepen your understanding of hypothesis testing and learn how to apply it with your own research analysis or yeah, that's all. Thank you.